Previously, we learned how to make a PERT and how to modify it by using various functionalities of the PERT module. Today, we'll learn using the property module. Now, in this property module, we define the material properties. We have to keep in mind that material and material properties are two different things. In property module, when we define a material, we're defining several material properties, which may or may not capture all the required behaviors of the material. That's very important to keep in mind. We can use simple material models. We don't have much experimental data for our material. For example, we can assume linear elasticity for strains less than 5%. And now, as you can see here in this module, we have many options to properly define a material's properties. For example, general and mechanical. Here we can define elastic or plastic properties, and also expansion or brittle cracking, viscosity, and also thermal properties, electric magnetic properties, or other. Now, before we get into actually modeling in the property module, let's get to some conventions regarding material properties. We are concerned with stress and strain when it comes to mechanical properties. For strain, this differs between nominal and logarithmic strain, and it denotes strain with different identifiers. And also, for stress, there is difference between true and engineering stress. It's defined differently. Second convention is about interpolation of data. Some material properties can be temperature dependent. Now, generally, experimental data are available for a range of temperature. ABAQUS will assume linear interpolation for tabular data. And what happens outside the range for which the data are available, it will assume that the value remains constant. Also, if some initial value, temperature, or variable is not provided, that is, any initial value is not provided, ABAQUS will assume that it's 0. The third convention is about the material direction. The default material directions depend on the element type. For continuum, it's global rectangular Cartesian system. For beam element, is according to the axis of the element. And there is also default material directions for shell and membrane elements. And linear elasticity assumptions are also very important when we're dealing with the property module. We can assume linear elasticity for very less strains, let's say for less than 5% strain. But in many cases, the relation between stress and strain is not linear. And for these cases, ABAQUS uses strain energy function, strain energy potential, instead of Young's modulus and Poisson's ratio, as we would have done for linear elasticity assumption. The function, the strain energy function, that can be phenomenological or curve-fitted, meaning that we can feed the experimental data to a function, and the coefficients of the function will be calculated. And the polynomial strain energy function is popularly used, which look like this. This much discussion is needed because the FEA simulation result will largely depend on how we are defining the material properties in the property module. We should get as much experimental data as possible, preferably test data for more than one deformation test, like uniaxial, compression, tension, biaxial, etc. So material properties actually come from experiments like popular uniaxial, biaxial, planar, or volumetric tests. Also, another brief discussion on plasticity. In many cases, we deal with metal plasticity because linear elasticity does not work in many practical cases like high stress. In plasticity, material yields and deforms permanently. Here, ABAQUS has several assumptions. One is yielding when subjected to higher stress and incompressibility. And also, hardening defines how the yield surface changes based on plastic deformation. We can define plastic deformation in several ways, like isotropic, kinematic, and combined. Detailed discussion on these, as you can find it in any plasticity related textbook. Focusing more on the ABAQUS modelings, here you can define plasticity of material in different ways. As we can see, in general, we can define the density, and also we can define the elasticity. Let's say we will assign two material properties to this block. The first one is material 1. For these, the density is, let's say, 1000. And mechanical elasticity elastic will define Young's modulus of 100, Poisson's ratio of 0.3. And we'll do OK. So in here, we can see that there is one material defined. We can edit from here. And also in the material manager, we can see that there is material 1. We can edit this. And also we can create another one. Let's say it's material 2. Density is, let's say, 2000. Or let's say it's 5000. And elastic is, let's say, 50,000, 0.25. I'm just putting arbitrary values as we do not, as we're not bothered about experimental data at this particular moment. And you can see that there are also sub options to define fail stress and fail strain. And we can also define plasticity data like plastic. Here we would have to define yield stress and plastic strain. And also we would be able to define different hardening criteria. But let's say we do not have this. We only have density and elastic parameters. And OK. And we can see in the material, we have material 1 and material 2. Now, about sections. Material properties or cross-section profiles are not directly applied to parts. Let's say we have a part and we want to define material properties to the part. How do we do it? Because we define a section and then assign the material properties to that part. How do we do it? Defining sections can be different in different geometry, like solid, shell, or beam. Let's assign a section for our part. Actually, two different sections to different portions of our part. We can assign material properties to different sections, but before that, we have to partition this. Let's go to part module. We use a create datum plane, offset from principal plane, offset from XY. It's asking for offset 10, so it will be divided midway. And create partition. So use datum plane. It's asking me to select this, so I select this and create partition. Done. So it has two partitions now, this side and this side. Now I go to the property module and I create a section. This is section 1. It's a solid section. It's a homogeneous. Continue. It's asking for the material. For this first section, I will assign material 1. Okay. You can see in the section manager, there is one section that contains material 1. I will do another section and assign material 2 section. In the material section, now in the section manager, we can see two sections, section 1 and section 2. Now I have to assign this section to the portions of the part. So I have to go to the assign section. It's asking for select the regions to be assigned a section. You can see that I can select this part, this portion of this portion according to the partition that I created beforehand. So I will select this one, the left portion, done. And it's asking me to assign a section 1, which will be material 1. You can see that it's showing the relevant information here. And you can see that the color has changed from white to green. So it shows that this portion has been assigned a section. That is, it has been assigned a material property. But this section is still white. So I will select this one now. Done. And section 2, which is material 2. So now the whole part has been assigned the material properties. Because the whole part has been colored green now, meaning that there is no portion of the part that is unassigned with material properties. If there is any portion of your part or assembly that has not been assigned with material properties or sections, you will see some error. The simulation will not run, which we will see in the later section. So in the section assignment manager, you can see that there are two sections. One is material 1, another one is material 2, and it's automatically given the names of the portions of the regions, the set 1 and set 2. So basically we have two materials, material 1 and material 2, for which the properties we've defined. We've created two sections and assigned the materials for them, and we have created two section names, section assignments, in which we have assigned the material properties to those two different sections or two different regions. So that finishes our discussion on property module. Hope it's helpful. Thanks.